Okay. So, continuing with the code, energy code, last class we were looking at, and we said that there are 3 types of options, that is prescriptive criteria, right, prescriptive criteria, which we had discussed, then trade off option, and then whole building performance. So, if you look at trade off option, last class we said that basic principle is if building envelope complies with the code in the building envelope performance factor of the proposed design is less than the standard design. So, a standard design is suggested for your floor area, etc., and where the standard design exactly complies with the criteria of the code. So, that complies with the criteria of the code, that is your prescriptive criteria and all that. Now, the envelope trade off equation, then it is given which is given in appendix 12. That means that actually it should perform better than the standard. So, standard is suggested which satisfies the prescriptive requirement all. Now, you can alter something one for example, you may have a better envelope performance while you might have a somewhat worse mechanical control performance. So, this a trade off is possible as long as the total energy consumption is in your building or your design building, proposed design is less than the standard. So, the trade off is allowed. Now, therefore, for that corresponding to, let us say you have a layout plan and the occupancy type, corresponding to that the standard design you can generate as per the guideline of the code, and then this should be this should be, this performance should be also, it gives you when you generate such a standard building, it will give its insulation requirement, etc., etc. So, those which are fixed like orientation and other requirement, functional requirement, area orientation, spaces, relative distance or relative adjacency of the spaces, all these are fixed. So, according to that you generate the standard design, which will have insulation requirement, SHGC requirement, and the requirement that we described in case of prescriptive criteria, all requirements will be satisfied. That means, your U values will be satisfied, SHGC will be satisfied for given window to wall ratio, the effect of shading, window to wall ratio and orientation, etc. So, those values are given, theta values, SHGC, U, those are given for prescriptive. So, standard design will satisfy all the prescriptive requirement which we have discussed earlier. Now, your building, when you look at its performance, overall performance, maybe calculate, estimates its energy consumption, annual energy consumption, that should be less than the one that is generated through the code's guideline for standard design. So, that is what it is. So, in that case what will happen? For example, you might choose HVAC, which is more efficient, more energy efficient, but maybe the envelope is performance is somewhat poor, maybe envelope performance is somewhat poor, but overall the whole thing satisfies. But there are certain mandatory requirements. So, certain mandatory requirements are there. For example, natural ventilation. Natural ventilation shall be minimum that is required for hygienic requirements. So, that is given as per, well, this is now changed to 2016 National Building Code. This gives you the ventilation, minimum ventilation, hygienic ventilation requirement. So, it should be according to that, and then cooling equipment should meet with the minimum efficiency requirement presented. The test equipment shall comply with SA these guidelines, etc. So, this split air conditioner shall meet IS 1391, packaged air conditioner should meet IS 8148, etc., and so on. So, these are the mandatory requirement. Here you have no compromise, you cannot compromise. You can compromise on certain other things. So, this you can have better, but not worse. Similarly, chillers. So, these prescriptions are given and this is mandatory. So, mandatory requirement you have to satisfy if you are doing a trade off. Controls, all mechanical and heating systems shall be controlled. I think I was mentioning this in the last class, might have a 2-point off-on control minimum, right. That means it is put on at 8 a.m. If the office is starting at 9 a.m., it is put on at around 8 or 8:30 a.m. and then remains there for 5, so and then is put off. So, there is a control system that has to have, can start stop system under different schedule, and as I was mentioning in the last class, 3 different schedule could be at least there. For example, a weekday schedule for office buildings, right, and maybe a half day schedule sometime, and third schedule is holiday. So, if it is a weekday schedule, it will possibly operate from 9 to 5 or 9 to 6 depending upon type of occupancy. Some cases even shopping centers, it might remain open for longer period of time during weekend, one day it might be closed and so on. So, this schedules according to the schedule it should operate, capable of retaining the program even if there is a power failure for at least 10 hours, and manual override has to be there. This is of course not required for if you have cooling system that consumes less than 28 kilowatt or 7K 8 tons and 2 tons heating system, cooling system, it is not required. So, there should be temperature controlled, both cooling and heating. So, plus minus 1.5 degree, as I was saying, plus minus 1.5 will make it 3 degree. So, that is what it is, what we call this is your desired value, design value, right. So, supposing I want to maintain this room, there will be a design value 25 degrees centigrade, let us say, or some cases it could be depending upon the situation, because our people in tropical climate can tolerate somewhat higher temperature than let us say somebody from subtropical areas. So, there it might be 20 degree and design value would be 20 plus minus 1.5, that means this band is 3. So, it should operate within 3 degrees, right, and so that's what it says, and then serve same temperature zone, thermostat shall be interlocked to prevent simultaneous heating and cooling. So, simultaneous heating and cooling would not operate, because usually cooling you would require in summer and heating you will require in winter. So, sometime some places it may be needed, but not simultaneously. For example, if it is a 24-hourly operation of a hospital, hospitals are 24-hourly operation. So, in that case maybe early in the morning you need heating and peak of the day, end of the day you might need cooling, but both you won't need together, either heating or cooling. So, that kind of control should be there, and right. So, generally the types of motors etc., the speed control and so on, those are also there. Piping and duct insulations are minimum specified, R value 0.70 and temperature, temperature of 60 degrees centigrade, operating temperature and so on. So, all these are mandatory requirements are specified. So, the point is that if you go for prescriptive means you do not do anything, just take the values. If you are going for a trade off, then you have to generate a standard design corresponding to your own design, and that will have properties. Since you generate it, it will have all the material properties, U values etc., all as per the prescriptive requirement. Certain things are mandatory, you have to maintain that and then check. After that you generate your standard design and your own design, you check, and if its performance is better than the standard, then it is acceptable. So, similarly for duct work, one of resistance values are given, insulation values, these are prescriptive, right. Then that then there is a clause related to system balancing, should be balanced according to generally accepted engineering standard. That means the quality of the HVAC system, there are some guideline related to that as well, and HVAC total conditioned areas, so these are provided, construction documents shall require that a written balance report provided by the owner to the owner or the design representative or building owner, etc., serving zones of total condition area exceeded 5. So, if your area condition area is more than 500 meters square, so certain documents are to be prepared, and all losses, etc., all losses, etc. So, this is to be also prepared. Okay. Location of the condensers and HVAC, etc., these are also specified, right. Water supply system must use soft water for condenser and chilled water system. So, compliance shall be demonstrated with the requirements for HVAC system is the following criteria: serving single zone, cooling provided by unitary package splits, etc. Heating is provided by a unitary package of split system, pump, fuel, electric resistance heater, and so on. Outside air quality is should be 1400 liters per second, air quantity, actually the quantity of air, the flow, and less than 70% of the supply air at design condition. Now, one thing you need basically minimum ventilation requirement or fresh air requirement for hygienic condition, but if you increase the fresh air requirement, cost of cooling increases, energy requirement will increase. So, that is why there is a less than 1400 liters per second flow rate is again controlled, right, and less than 70% of the supply air at design condition. So, what we do is we mix up two airs, right. So, air from the fresh air comes, and this is the recirculated air, some air is recirculated, right, or let me draw it somewhere here. Fresh air comes like this, recirculated air, which will be at room temperature, This is fresh air, and this combined mixed air, this is then will be some mixture temperature. It will be not at room temperature, neither the fresh air temperature, it will be somewhere in between. So, this will be, this air will be cooled lower than to a temperature lower than room temperature, right, and as it enter into the room, it will again gain heat and its temperature will increase, and that would attain the room temperature. So, air at lower temperature enters the room and attains the room temperature, that is how it absorbs the heat. So, cool to lower temperature, as I said, cool to lower temperature. So, if I increase this fresh air intake, that means outside air temperature might be 30 or 35 degrees centigrade or 40 degrees centigrade. This air might be at 25 degrees centigrade. So, following law of mixture, this air temperature will be somewhere in between, say 40 and 25, somewhere in between, right. Now, I have to cool it to lower temperature than room temperature. As it enters into the room, it will absorb the heat. Now, what it is saying is that I must have fresh air requirement less than 1400 liter per second or 70% of the supply air condition, or 70% of the supply air condition, 70% of the supply, that means 30% can be, right. So, outside air quantity shall be less, minimum 30% should be recirculated air, minimum 30. So, this will, but it is much higher, usually it is much higher, right. So, to reduce down the cooling energy requirement. Okay. Water cooled air conditioning or heat pump units with a circulation pump motor greater than equals to 3.7 kilowatt shall have two-way automatic isolation bulbs. Water cooled air conditioning or heat pump unit that are interlocked, that is, if you have both are together, then you should have isolation bulbs. So, one goes, other does not work. Similarly, such prescriptive requirements are also given for service hot water pumping. That means, these are mandatory requirement, even when you have even when you have trade off option. So, centralized system shall have solar water heater minimum, at least 1/5 of the design capacity should be through solar heat water, solar. Service water heating equipment shall meet and exceed the performance of minimum requirement presented in available Indian standard. So, heating equipment must have the efficiency as per the standard, and 1/5 must be solar heater. Supplementary heating system shall be designed to maximize the energy efficiency of the system and shall incorporate the following design features: maximum heat recovery from hot discharge system like condenser and air conditioning. So, as much as heat recovery is possible, because an air conditioning system, or if you just look at refrigerator, what happens is backside is warm, right. In an refrigeration system, the refrigerant is compressed and then it evaporates again in its 4 cycle, and while evaporating it takes the heat from the chamber from wherever it is supposed to take heat, right, where it is supposed to cool. But again it becomes by it it absorbs, becomes vapor, and under pressure it becomes liquid again. So, then when it becomes liquid, it will actually dissipate that energy. So, that energy, if you can recover this, it has to be recovered, that is what I am saying, as much as possible. So, maximum heat recovery should be, so there should be a heat recovery system as well. Use of gas fired heater wherever gas is available, electric heater is usually last because of the efficiency and so on. The entire hot water system includes storage tank, pipelines, that is as per design, and okay, shall have heat traps on both inlet and outlet, and heated swimming pools, if they are there, shall be provided with a vapor grade retardant pool cover. So, minimizing the loss, and pools heated more than 32 degrees centigrade shall have a pool cover with a minimum insulation of this. So, these are the mandatory requirements given. Application of approval shall furnish all this detailed. Wherever gas is available, not more than 20% heat shall be met with electrical heating. So, if gas is available, use 80% by gas, 20% on electrical. Similarly, lighting requirements, interior space building, exterior building features, and exterior building grounds lighting, that is provided through building electrical service. So, all this lighting requirements shall apply to all this. Whatever lighting requirement, I think we discussed some of them during prescriptive condition. So, that should be met, right. Okay, it is already given. The interior lighting system of the building larger than 500 meter square shall be equipped with automatic control device. So, when you require, you put it on, otherwise no. Within this building and office areas less than 30 meter square enclosed by walls or ceiling height partition and meeting conference room, etc., shall be equipped with occupancy sensors. That means, as you enter, the lights is on, as soon as one is out. So, it is intelligent system sort of. Essentially, they could be infrared sensing. So, if somebody comes in, it senses and the lights becomes on. So, it also says that you can put in. Each space enclosed in ceiling height partition shall have at least one control devices to independently control and general lighting within the space. Each control device shall be activated either manually by an occupant or automatically by sensing the occupant. Okay. Okay, then it also talks about the fitting, light fitting, luminaires in daylighted area greater than 25 meter square shall be equipped with either a manual or automatic control devices. So, luminary is light on the fitting. So, it should be capable of reducing the light output of the luminaires in the daylight areas by 50%. So, try to utilize maximum daylight, and controls only of the luminaries located entirely in within the daylighted area. Lighting for all exterior applications shall be controlled by a photosensor or astronomical time switch that is capable of automatically turning off the exterior lighting when daylight is available or lighting is not required. So, first is the prescriptive. Now, this is all descriptive information, but if you know the information, you can make compliances. You can look at the code and then you can use the compliances. The strategy is threefold. One is prescriptive, which is not a very best strategy, because you can, the freedom is not there then with the designer. The second strategy is the trade off, and third, of course, we will look at the whole building performance. Now, here through building area method, interior lighting, total lighting per unit area is given in table. For example, for a classroom floor area, how much watt So, this is given in tabular form. Gross lighted floor area of each building time one can calculate, and interior lighting power allowances for the sum of the products of gross lighted floor area of each building times the allowed lighting power density for building area. So, basically it is telling you how to find out the quantity of lighting required, and this is what is given in tabular form. So, from building area method you can find out what is the lighting required, right. Lighting power demand is for automotive facility, convention center, these values are given, museum. So, per unit area watt per meter square, therefore, how much lighting is required is given. Okay. Some cases it might be you can find out the lighting through space function method. Determine the appropriate building type again from a table. Each spaced enclosed partition is 80% or greater than ceiling height. Determine gross interior floor area by measuring the center of the partition, include the floor area of balconies and other projection. So, retail space do not have to comply with 80% etc. So, interior lighting power allowances are sum of the lighting power allowances for all spaces, and this is again another table it is given. So, here it is given again lighting power demand for interior lighting power that is required. So, for building exterior lighting application, this is a building entrance 13 watts. So, here not this is given area wise, it is given entrance this, exit this much, building facades this much, all right. So, whole building then this is all related to trade off. So, trade off, these are the mandatory requirement. Now, the last is prescriptive, then trade off, last is whole building performance method. In this one again you have to generate. So, whole building performance method is an alternative to the prescriptive requirement given in the standard. Now, this is a basic thing, a building is said to be complying with the whole building performance method when estimated annual energy use of the proposed design is less than the standard design. So, again you generate a standard design, right, even though it may not comply with specific requirements of the prescriptive requirements. Now, there somewhere you can previous one you can violate somewhere. Here if you have come up with an innovative design, you can violate little bit in all of them. Actually, the prescriptive one, if you remember that I said that they is generated based on life cycle costing and about 8-9 points regression. From that they actually found out what is the insulation value, what should be the solar heat gain coefficient and so on. Therefore, this is grossly conservative. So, if one looks at whole building performance, right, then it is it's much more flexible. You can do it in your own way and just show that this is better than the one that would follow the standard design. Okay. So, that is it. So, mandatory requirements again has to be followed. So, the mandatory requirements must be followed. So, annual energy use, of course, you will calculate whole building performance, calculate kilowatt hours of electricity per year. Energy sources other than electricity which are used in the building shall be converted into kilowatt of equivalent energy, electrical energy at the rate of 0.75 kilowatt per megajoule. So, any other, for example, if you are using a boiler, steam or something. So, whatever megajoule power you have, convert that into equivalent electrical, and then use simulation programs. Now, these simulation programs also it is specified or given some range of simulation program which you can use. So, it would calculate out H760 hours of the year, that means for every 365 day 24 hours. So, such as energy plus equest etc., they can calculate out. Now, in design, if you are designing the building envelope, you do not need this kind of robust calculation for that many hours. What you need is compare, you might take a typical summer day, typical winter day, or maybe combinations of them, number of them maybe, and then find out in case of design and find out relatively which is better. But this has to be a robust calculation. That means, every hourly estimation of energy should be there, and it must take into account of hourly variations in occupancy, lighting power, miscellaneous equipment power, all, and such software can take care of this. Thermal mass effect of the overall building, then they calculate internal heat distribution also. If somebody is designing only the envelope, they need not look into internal heat distribution in a big way, but this should also look into the internal heat distribution. For example, for this building, this is facing, this is facing southeast, this side is facing southeast, this is facing a corridor. Now, this will gain some heat, corridor, there will be heat transfer from this space to the corridor, and the other one, if other side, if I have another, some other room which face northwest. So, in the afternoon maybe heat, there is a heat coming in from those spaces also. So, internal distribution of the heat, cooling load or heating load between all the rooms, has to be also found out. So, normally you have divide the building into zones. So, thermal zones actually. So, interzone heat transfer is also to be taken into account, and part load and temperature different performance of heating and cooling equipment, that has to be taken, because part of it might be part load, some of those could be temperature dependence itself. So, the temperature different load might be a function of the temperature, and part of the time the load is actually part cooling I need, I do not need whole cooling, some portion I may not be applying the cooling and things like that. So, if there are something like evaporative fountains, or some economizer I am using or integrated control I am using, the software should be able to take that kind of thing. So, this simulation program shall calculate the hourly basis, values of climatic data, temperature, humidity from represent. Now, that is the problem. Normally most of this software will have a data bank, many of them for all major cities of the world. So, they will have data bank, but there are other societies, for example, Indian Society for Heating, Refrigeration and Air, ISRE, air conditioning, they have data for Indian sites. Similarly, ESHRE will have for American and so on. So, even ESHRE has got for some Indian data, because the softwares developed in America, they will have, since this is used elsewhere also. So, they have international data in fact. So, you have representative data, that means you are actually according to the representative data you are trying to find out whether this will be complying with the requirement or not. It does not mean the next year you will find energy as you have calculated, because every year temperature and relative humidity, air velocity or climatic parameters, they are not same. So, weather parameters are not same. So, therefore, this should be this is for compliance purposes, the standard data is used, right. Okay. So, compliance with the performance based, that is what it is. Proposed, this is the guideline, proposed building design, basic requirement must be met. That means, fundamental is say structural safety, that must be met, and as we said in the beginning, as and when this comes, this safety comes into picture, they will override the energy codes requirement. So, basic requirement must be met, that means fire safety, structural safety, this must be met. Then you design the building, maybe have alternative designs, corresponding to that you will have a reference building which might be same, because your functional requirement is already finalized and location is finalized, maybe you have followed the bylaws, orientation will shape orientation, that may also be finalized, but if there is a variation one can take it. So, this is building description. So, according to that you generate the reference building, and this is your design building, design energy computation, total energy budget comes from there, building energy analysis you do. So, if the consumption is less than the budget, then this is accepted. Okay. So, then it complies with the code. So, that is how the code works, that is how the code works. So, that is how the code works. So, for example, basic proposed building meets basic requirement except from prescriptive and system performance requirement. So, no prescriptive requirement here, it won't. And this is the reference building, meets basic requirements, meets prescriptive and system performance requirement. This gives me from simulation energy cost budget, and this gives me design energy cost budget, right. This should be less than this one. So, as long as your design gives you, it is satisfied, it is it's satisfied, right. So, this is as a system, for example, this is daylight features, all daylight apparatus you might have. This is a building envelope, lighting system. So, envelope part, lighting system, controls, then energy management system control, actually high efficiency service of hot water, visible speed control, exhaust etc., high efficiency chiller, high efficiency heat exchanger. So, you might reduce HVAC load because of the envelope and lighting etc., and then use an efficient system, high efficiency process, and all this when complies you will automatically get this. So, so general framework of the building energy codes, if you see any code actually, there will be some mandatory requirements. Safety is for example one of them. Besides that, this mandatory requirements, some building envelope, lighting, HVAC minimum, electrical, lift escalator, service water system, and then prescriptive requirements, system compliance, energy budget cost, whole building, system or component. So, here the trade off means system, some system complies, some component complies, not all component. Prescriptive means you do not you just took the values from the code and used them, and this one some components will, some component may not, but it satisfies the requirement, and the whole building performance deals with energy cost which should be less than the standard. So, that is what it is. So, we look into some other kind of codes. Let us see what is the status of the code elsewhere in the world, slightly somewhat some years earlier, but even this, because of history, a little bit of history, and then we will go to any other kind of approach to control the energy, right.